Now today's job is to implement something which I'm not sure I've done before. I've done very similar things. So my approach to constraining is to initially to fix the backbone topology completely, and it's best to retain that above all other consideration. I think this is what people mostly will have interest in. And then, but I have an optional downstream is to add any components of like species comprehensive data which can't be fit directly into the terminals of the backbone tree. I have the option to add these as soft constraints. But the soft constraints are only taxonomic in nature, and so it's just when considering the species rich comprehensive data, such as DNA barcodes, it's a case of looks at the source tree or the backbone tree. Is taxon X monophyletic or not? If it is, find it in the barcodes and code the members of that taxon yes 1, and everything else 0. But what I want to do is have relational constraints, soft constraints. So what this would be is this will correspond to a bifurcation of a source tree or a backbone tree. And importantly, unlike a taxon constraint, it doesn't correspond to a single taxon. It will correspond to multiple taxa. Now, I know recently, well, not too long ago, I looked at Beninda and Mann's the supertree implementation in Perl, and that would be roughly the similar thing in coding bifurcations. And I suspect I've done something similar. So first, I haven't checked yet what actually needs to be done. Only I can really show what the problem is. So here we have a B genus Anthophora and Armagilla, another B genus. These should be sister to Anthophora, and they are not here. Now this is not in the. This can't be determined. So this is the main omics backbone tree, and Armagilla is not represented here. So it can't. This bifurcation, this relationship cannot be fixed. It needs to be. But this information is contained in in a source tree, so it needs to be coded as. Here it is here. Cardinal et al. 2010 have Armagilla sister to Anthophora. So I'll use this source tree and try and code a softer bifurcation constraint, and add this as a in the matrix along with the otherwise fixed topology. So the first thing to do is I need to I need to check one thing which is similar and figure out if it's the same thing or not. Now the relational constraints, I seem to remember I've coded these in fast tree format, which is kind of similar to, it will be a similar format. I need to check first if I can adapt this. Okay, I'm just gonna well, I'll need to look at the outputs first. So normally I run relational constraints on a omics backbone. So instead here I'll just be running it on a source tree. Okay, so let's just run this, see what happens. Okay, here we go. Okay, this is a bit too big to. It's a bit too big to interpret. So what I think I'll do is just make a very small test phylogeny. Okay, let's take a look. So from this small source tree, we have these constraints. So what we're expecting is Armadillo and Anthophora to be part of a group separate from, say, Hapapoda. Now at the same time, we can see here they're also separated within for each group, which is fine, and we have a trait here. Now we have a lot of stuff missing. This is okay as long as it encompasses the components of the source tree. So importantly, we need to check that at least one of these is present. So let's look. Apopoda, let's have a look for this. And we seem to have this. Okay. So let's look at these together. So Hapapoda has a different state from Anthophora and Armadillo. And we have an additional character for Hapapoda. So this looks good to me. So we have Armadillo and Anthophora share this state, and it's different from Hapapoda. So this looks, I think we can adapt this to the soft constraints, soft topological constraint. So what we'd need to do is change these dashes to missing data character and appropriate IDs. Okay, so we just need, I think there's not much changes required actually. And then I think we could try this. So we just need to be writing this in faster format, I think. I need to set the missing data character, and that's about it. So we'll have it binary. I'm not sure what to write bin, or maybe binary something also means something else. So we print our output. So we set, okay, so we set another, open another file handle, a new one, always have to call it something different. Write to, forward arrow means write to, if we had to, that would mean append to. Name has to be in double quotes. So I'll just put, I'm not really sure what's the best name, so I'm just going to put, let's make sure this name is not been used before. Close the file handle here and then write to the file handle here. Now we're also already printing something similar, so I just need to write this in. So this, I implement soft constraints as roughly in faster format and concatenate these two matrix as those binary characters. So faster format, we just need to write an arrow, new line, \L, new line, and presumably these are the set of characters and another new line. So this should write faster format. So let me check what these, what's the difference between these two. Oh, okay, I know. So some will be tab separated and some not. Okay, see if this should write. So we have faster format, binary characters for all the splits in this particular source tree. There's a lot more data here, but this just covers the taxon of this small test source tree we've used, and we'll be adding lots of different source trees to this. But yeah, for the current part, I just want to fix this one problem. This should have the information to do that. And so forth. So missing data is set as a hyphen, but I've actually recently implemented. You can standardize the missing data character during concatenation. So I'll have these all changed to question mark. Now, in principle, the default behavior of phylogenetic analysis is all missing data characters are treated the same, but I suspect there's cases where this is not so. I did notice something once, so just to be careful, I don't want to have gaps, and I don't want to have hyphens and question marks in the same supermatrix. So I'll standardize those. Okay, so this is a new bash variable, source tree. I might probably run this for a lot of source trees. Always delete the previous output file, which is current focus, and then and then change the name to contain the source tree name. It might not be relevant here. So I won't perturb this. Don't need this. Okay. And here's our output. So this is the full source tree, and here's a problematic taxa, and hopefully this will now be fixed. So I need to now incorporate this into the super matrix. So concatenate this. The existing matrix has the super matrix has a DNA barcode and taxonomic soft constraints. So we'll be appending to this relational soft constraints. I call it relational, but I'm not sure what the correct name is. But this is basically a bifurcation. So we'll attach that. I'll add a high weight, we'll make sure it's actually working. Change the format to Phylip, which is used by XML. Change all the names. Okay, one thing I've haven't yet got around to is auto detecting binary characters, so to manually change the binary partitions on the rocks. So I've been procrastinating, but now we should have, I can see that now I have this last partition, which is a relational constraint, relational soft constraints as binary characters. Save, and this should run. So we're running MaxML, MPI version, 6 processors, constraint tree. And we're going. So this is going to take a few hours to run, so I'm going to can't confirm whether this actually has the effect we expect, but from inspecting the matrix, this is what seems to be what we want to make, to incorporate bifurcation as soft constraints. Strange, I'm just wondering why I haven't done this before. Well, I've kind of done it before, but I'm not sure I haven't used this for. I haven't used this much. So traditionally, I've always had I always prefer to fix the backbone as much as possible. So I don't really. I use soft constraints on when I have to. Maybe that's the reason. But anyway, so yeah, job seems to be done, and hopefully this will place Armadillo and Anthophora as sister taxa on our result. So you can see the previous result, and we have so these are all Anthophora, and we have sister to Habipoda, whereas we want, according to one of the source trees, Armadillo should be here. Well, we'll see. Anyway, job done for now, and until